Good afternoon, everyone. Yeah, my name is Max, and I want to talk to you about GitHub Actions, which is a new dev workflow automation product from GitHub. I've been working for our studio on a package that kind of brings GitHub Actions to R, and I want to report on sort of my experience and maybe offer some reflections on what GitHub Actions can do for the R community. I'm going to focus mostly on continuous integration and delivery, CI/CD, even though GitHub Actions does a lot more than just CI/CD, and I'm going to focus on that mostly because it's kind of the meat and potatoes of workflow automation, and we're familiar with it, and there are competitors, so it's maybe a good foil to kind of understand and evaluate the design of GitHub Actions. Now, what is CI/CD again? It's kind of our attempt to solve this problem, right, that we're all familiar with. It works on my machine, doesn't work on your machine, everyone's frustrated. We're already pretty well set up in terms of reproducibility if you're using an R project, right? So let's say you have some script, your data wrangling in the analysis in a .rmd, and you run it to R Markdown render to get your project. Same thing if you have a source of a package, and then you compile it and you have your binary. But there is sort of a hidden variable included here, and that is, of course, your computer. And there be dragons, right? There could be weird versions of dependencies and compiler flags and environment variables. And the problem with those is that they're not usually very well documented on your computer. And that's where CI/CD comes in conceptually, right? So basically, the solution to your computer, my computer doesn't work for CI/CD is let's have a third computer. And the difference for this third computer, the CI/CD server, would be that we make sure that we have a very well-defined computing environment there, and that we do have these things like compiler flags, environment variables, etc., that we have them well documented. And they could be in a Dockerfile or Travis, or depending on which service you use. And then you get rid of this hidden variable, and at least sort of as a regulative ideal, it should get a little more reproducible. Now, before I move on to evaluate GitHub Actions, let me just show you what it does. You can use our package called GH Actions, and it has a bunch of use this styled helpers, which really, they're just templating functions. They set up the necessary config files that you need for typical kinds of projects. For example, for an RMD website that you might want to compile and then push out to, let's say, GitHub Pages or wherever. And you can just run this helper on your machine, and you push it off to GitHub. And if you then go to github.com to your repository, there should be a tab Actions, and it should give you a little graph like this, which goes through the stages, builds the image, renders your project, and then filters on master, because maybe you want to deploy the other branches, and pushes it out to GitHub Pages or wherever. Now, you might ask, why do we need another one of those, right? We have Jenkins, we have a lot of Jenkins, we have Travis, a lot of people in the community use that. Why do we need another one? Well, I'm not sure that we do, but there is at least some need, right? I mean, let's be honest, CI/CD is a great idea, but it occasionally causes more problems than it solves. It can be very frustrating, a huge time sink, especially for relatively smaller projects with people who don't dream DevOps every time, right? And this isn't on Travis CI or them. It's mostly the problems are caused by us, right? We make the mistakes. It's just a question, I think, of what happens when things go wrong. They will go wrong, and the question for a good CI/CD workflow should be how easy it is to reason about. And I think GitHub Actions has some aspects in that department that recommend it to make it sort of easy to reason about. First up, let's talk about the definition of the computing environment. How exactly is that defined? Now, on Travis or other services, first of all, the computing environment will be defined by the service, and that may be proprietary or maybe not. I think it's possible to reproduce the computing environment for Travis, but it's a little finicky. And then it's also defined by a travis.yml, which basically speaks to some kind of script that the service provider is running for you. Now, on GitHub Actions, this is arguably considerably simpler, or at least more transparent, because actions are just Docker files and default entry points. That's all they are. Every action just has an action, and has a Docker file or Docker image, and it runs the default entry point, and that's that. And you can reproduce this locally on your machine quite easily. You build the image. Actually, most actions, our actions definitely are published to the Docker Hub registry, so you don't even have to build it. You can just run docker run, and maybe you want to override the entry point, and that gets you right there on your machine. And GitHub Actions, the config file that they use, it's a main.workflow, just a text file. It's a very, very thin wrapper around Docker run, really. So first line or second line here, uses, that's really just the name of the repository that contains your action. And what's neat about it is that you can append any GitHub reference, any Git reference. Could be a branch, could be a commit, could be a release. And that's kind of neat. So you can make sure that your CI/CD workflow won't break just because someone updated the CI/CD tool, right? And that's exactly like that sort of gets passed down to Docker run as the name of the image plus the tag. Same thing for secrets and other environments. Environment variables, they just get passed on to Docker run as environment variables, right? So it's really easy to get this to work on your machine. You go to your terminal, you paste the Docker run invocation there, maybe you map your working directory to a special place in this thing, and then you're already in there. You're already in the computing environment just as it runs on GitHub Actions. You can look around like, what's up here? You can enter R, and you can run functions inside of R just as they would inside of GitHub Actions, right? Because usually if we have a problem in CI/CD, it's because we have some hypothesis that turns out to be wrong, right? And so it's good to be really quick in like validating these hypotheses and being able to do that locally and just like looking around and like, what's going on here? That I think is just good. It's very efficient. Moving on to how's the workflow graph defined, and the word kind of gives it away. On GitHub Actions, it's just a directed acyclic graph, DAG, using a subset of the HashiCorp config language, HCL. And that sounds fancy, but it's really quite simple. We can reason through this very simple example. Let's say you want to deploy a Shiny app. And so you say on line 2 here, on every push, you want to see that the resolve target deploy to shinyapps.io, that gets resolved. And then GitHub Actions will look for an action that does that. That will be the last one here, line 8. And it turns out that one has a requirement itself as a dependency that needs to install the dependencies first. Maybe you're using ggplot or whatever. And so it first needs to run the action in line 5, and then it runs the action in line 8, and then it's done. Now this is really easy, but you can also run considerably more complex workflows that you can see on the right here. That's actually the workflow that is driving the package development that I'm doing here. I'm sort of dog-fooding this. And you can write arbitrarily complex workflows. You're not bound to the predefined stages that a lot of the services are using. You can just, as long as you can reason your way throughout your dependency graph, you're good. And they really just pass on the exit code. They're just entry points passing on the exit codes throughout this graph. And this allows some neat things because each action is its own Docker container rather than sharing one compute environment. You can have different dependencies installed and all sorts of different computing environments in the different actions. So for example, maybe you have a project that both has a Shiny app and an R Markdown project. So you want to render the R Markdown project, push it off somewhere, but you also want to deploy the app to shinyapps.io. And you can have one action, you can use one action for the first step, which obviously needs R Markdown and whatever other dependencies that has, and you have another action which has Rs Connect or whatever you might need to push. And other than what you explicitly state that these two actions should share, and that's everything that's in /GitHub/workspace, they will share nothing. Those are like completely fresh machine space just on the images that are driving those actions. Lastly, let's talk a little bit about the API ecosystem. And this isn't something, I guess most of this is also possible in other services, but GitHub makes it a little more transparent and therefore just easier to set up and also easier to reason about. You can take a sizable subset of the GitHub API both as inputs to your actions as well as use the RESTful API as outputs to your actions. So you can go nuts. You can, I don't know, have some action that triggers whenever there's a new member in your repo and use R Markdown to update your website with the contributors or whatever you want. You can also just use CI/CD and do things on Git push events, of course. Here's one that we built that's a little, that sort of takes advantage of this. If you're building a package and using Roxygen 2, I'm betting that some of you have occasionally forgotten to run Roxygenize and push the thing, and then whatever is in /man is sort of out of sync with your Roxygen comments. And that happens a lot, especially if like you have contributors who just want to like fix a little typo. And we have an action, and it's quite easy, that will run DevTools document on your project on every commit, and it'll see if there's a diff. And if there's a diff, it will commit that diff as sort of like this little bot actor here called rlib /GH actions. So that's one way. I hope that we'll be able to explore many more of those, just to sort of speed up development and provide these little helpers for open source development. Right, so what does GH Actions, the R package, actually do? It basically does 2 things. I've written a bunch of actions, that is Docker files and default entry points. Actually a bunch more than those, and I hope to add many more. Some of them are useful for CI/CD workflows, so you can run build, check, code-cov, document, and then a bunch of other actions that you might need in other sorts of projects for R Markdown, package down. You can talk to Ars Connect, those kinds of things. And then I also have sort of templating functions styled on useThis, that work kind of like useThis does, to set you up with like ready-made workflows for typical R projects, such as packages or Shiny apps or R Markdown projects. And you can also deploy to use the actions necessary to deploy to some of the usual suspects, Netlify, GitHub Pages, Firebase, etc. And those will simply just paste the necessary text files with the config into your repo. And if you then want to, you can go on and configure to your heart's content. This isn't some, I'm not like, this isn't a DSL that sort of wraps around HCL or whatever. It's just pretty plain templating. Right, so does this solve our problem? Well, not sure it solves it, but I think it does make it easier. Docker is an elegant abstraction, and mostly what I think is attractive about GitHub Actions is that it makes this very transparent to the user and really easily accessible. So I think it is easier-ish to reason about things that go wrong, as they inevitably will in development. And I think that recommends GitHub Actions also for our users. Now, there are some caveats, I should say. GitHub Actions is still in limited beta, so you may not be able to use it unless they sort of took you off the wait list. You can get on the wait list. I'm guessing it's going to be out of beta sometime soon, but as of now, it still is. And with that comes some limitations in features. Now, I should say I obviously have no inside information on what GitHub will or will not do with the product, so I can just list these limitations as I've encountered them. For now, there's no native caching, so you either have to live with relatively slow builds or you have to roll your own caching. There are no real-time logs, as we're used to from some other services. Documentation is relatively sparse, as we might expect for a better product. And sort of bafflingly, but if you understand design, it kind of makes sense. There's no support for pull requests as of now, because actions always run against the repository to which the push or whatever event it was made. On the upside, of course, it's one less service to authenticate against, right? So that and just one less service to worry about. Long-term caveats and advantages, it doesn't seem like there'll be cross-platform support or support for matrix build, because it's just individual Docker files, so that might be hard in there. I already said that about the documentation. You have really easy access to the GitHub API. I said that's pretty cool. There's some talk and also already some kind of marketplace and potentially maybe an ecosystem of sharing actions. There's another thing. We can share actions between ecosystems. We can use deploy actions that haven't been built in the R context, because they're just Docker containers. And even though it's obviously a proprietary service that might cost something at some point, it's a pretty thin layer, and most of it is open source, and that should limit vendor lock-in considerably, I think. So with that, I want to thank Jim Hester for our studio, who's been shepherding me through this project during my summer stint at our studio, and Gabor Chardi for the R-Hub project, and Dirk Edelbüttel and Karl Böttiger for the Rocker project. who've sort of put in the hard work into making these Docker containers for R, and without whom this wouldn't be possible. Thanks, and live long and prosper. All right, that's my talk.
So, any questions?
Hi, thank you for a very interesting talk. So this might be the most stupid question, but I'm stuck with using GitLabs at work at the moment. You mentioned you can run the Docker containers locally. Can we use this in some sort of local configuration?
So you're saying you're using GitLab?
Yeah.
And that's hosted on-prem?
No, not on CRAN.
Okay. Well, I'm not familiar with the GitLab CI offering. I know that they have something there as well. So, and I'm guessing that, yes, you should be able to reuse the images that we've built for GitHub Actions to drive CI there, because they're just open on Docker. But then again, I should say these images they don't add a lot on top of the images from the Rocker project or the RHub project that I just mentioned, right? So you might as well just use those for CI/CD, especially the RHub project, which is sort of geared towards providing actually a whole variety of images for running CI/CD in R.